Hello friends, welcome back to my channel. Now in today's video, we are going to look at a drift detection monitoring system for a machine learning application. And for that, we will use Prometheus, Grafana, Alertmanager, and Slack. Alright, we have an end-to-end MLOps project here where we have a machine learning application built using Python and FastAPI. And we use a FastAPI to expose the /metric endpoint so that we can collect metrics from our model. Now this metrics endpoint that will be exposed is what Prometheus is going to use to collect metrics. Then we will simulate drift detection using statistical methods, namely the Kolmogorov-Smirnov test, that's the KS test, and the population stability index, which is a PSI test. Now we usually use the KS test for numerical data or numerical features, and we use the PSI for categorical data or features. Once drift is detected, we will collect the metrics or data in Prometheus and visualize it on a dashboard in Grafana. Once drift is detected, alerts will be collected by Alertmanager, and notifications of the alerts will be sent to a Slack notification channel. Now for all of these servers that we will need, namely the Prometheus, Grafana, Alertmanager, and that of the machine learning app, we are going to run them in a Docker Compose file all as one. Like, comment, and subscribe to my channel for more videos like this. And now let's get into it. First, we talk a little bit about the project structure. Now there are certain directories and files you have to create for this project. Now first, for the directories, you will need, of course, our current directory is the drift monitoring. Now you will need the directories Prometheus, Grafana, /provisioning, /data source, and dashboards. So you can clearly see it here. If I click on Grafana, you see provisioning, dashboards, data source, and inside of them, there will be files. Okay, right. This is how you create a nested folder using mkdir. And then we will create model service. This is where our app is going to be, Alertmanager and stuff. So using that, you create basically all of these directories here. Focusing on our main model service, we have some files in here for app.py, that's our actual application. We have datagenerator.py, Docker file, driftdetector.py, and requirements.txt. Now app.py is the main API with our endpoints, okay, for our machine learning app. Drift detector, of course, as the name goes, this is the Python script that's gonna have the KS test and PSI algorithms in there. And then we have a datagenerator.py. This is gonna simulate some synthetic data that we will use for our project. And then later on, we will inject real-time drift so that we will see how the detection will look like. So if you look at the app.py, if you go in there, you should see that we are actually importing those other files, those two, from the driftdetector.py and datagenerator.py in here. And this is actually how Python imports packages and stuff like that. You can literally write a separate file and then just import it into another file. I will not waste too much time on this, but this you can clearly see it's a FastAPI application and it's gonna create our model. I will leave the link to the GitHub repository in the description below so you can look at it. Back to the README. Now, if you look through the app, you'll see several endpoints. Okay, we have some get and post endpoints. Now the / is the home endpoint, and that is exactly what you see here, right here. That's the root endpoint. You have /predict for making predictions, drift status. You have simulate drift. You have the metrics. This is the endpoint that the Prometheus is going to use to collect metrics. And then you have a health check endpoint. And you can find all of them here. This is predict. This is the drift status, etc. All right. I will also create some files in the root directory of the project. You basically have a .env file. Now this is going to contain a drift threshold environment variable and the Slack web URL that we will create for our Slack notifications. I also have a Docker Compose file here. This is going to contain all the services that we're going to use. Because the first one here is the model service itself. The next one is Prometheus. This is the Alertmanager, and then we have a Grafana here. Because we have multiple containers that are going to run in tandem, we need to make sure that they are all on the same network. So if you code it, you'll see that for each service, I specified a network called monitoring, right? And that is for every single service here, right there, for all of them, including the model itself. Okay. Now, when you do that, then you can specify networks as monitoring, which is the name we gave it. And this is of type bridge. And then also we will have some volumes attached to them, right? So that is our Docker Compose file that will run everything for us. And of course, you have a README. You have test_normal.sh. This is how you will inject some drift by trying to make predictions. And this will do about 100 predictions to see how the drift is going to look like. This is basically some traffic that we will try to use. And then, of course, at the end, we will need to clean up. So this is how we are going to do our cleanup later. So back to our README file. All right. Now let's look at how to build and start the services that we're going to use for this project. Let's first go through a little review of each of them. We've done the model services already. Now for the Prometheus, of course, I've already shown you the Docker Compose file. If you scroll down to Prometheus, this is it. You're using the prom/Prometheus latest Docker image for that. Then we are using the Prometheus as the container name. Port is 9090. And we are attaching some volume here. Now, we are going to send alerts based on the rules that are set by the Alertmanager. Basically, the alert rules. So we have an alert rules file here that we are going to use for sending alerts. Now, we need to mount this into the Docker container for Prometheus. So we are mounting it in Prometheus at etc prometheus alert rules.yaml. Now, you should also see that in the Prometheus file, which is prometheus.yaml right here, where we specify the rules file. This is what we mounted. For this to also work, we need to give it the configuration for Alertmanager, which is what this exactly is. Alertmanager, that's going to be the name of the Alertmanager container, and this is the port number, 1993. So back to the Docker Compose. These are some basic commands that we usually add to the Prometheus container whenever we are starting it. And of course, the network is right there. Next, for the Alertmanager, we are using the prom/Alertmanager latest container image. And like I mentioned earlier, we're using Alertmanager as the name of the container. That's why in prometheus.yaml, we specified the Alertmanager here, which is the exact name right there. Right. Next, we will attach some volume here. And of course, the port is 1993. And then some commands here. And of course, has to be on the same network. Now, if you go to Alertmanager directory here, we have the Alertmanager rules and the Alertmanager configuration itself. Now, the configuration basically tells us the alert type, whether it's severe or not, and the time intervals and all those kind of stuff. So you can easily go through this, whether it's critical or the alert is not so critical. This is what's going to specify that. We will have to change the Slack API URL. We will create one and replace this with a new one. So that will come later. And then in alert rules, this is where we will set a threshold for our alerts. If the model drift score is greater than 0.03, then this will send an alert to our Slack. And you can set several scores for different things. If model service is 0, this basically means the whole service is down or our model is not currently running. This should also send an alert and stuff like that. Okay. So that's for alert rules. Compose. Next is Grafana. Of course, this is for visualization. This is the Grafana Docker image we are using for this project. And we are calling our container Grafana. Port is 3000. And usually Grafana has username and password admin at the beginning. But then you have to change the password after that. And then, of course, some volume. It has to be on the same network as everything else. Now, Grafana is going to collect the metrics from Prometheus and visualize it. So this has to always depend on the Prometheus container. Now, I'm using Prometheus here because that's the name of our Prometheus container right there, right here. Then of course you specify networks and all the volumes you've specified. And then if I go to the Grafana /provisioning /data sources or dashboards, you have two directories here. You can actually set all of this up inside of the Grafana UI, but I'm deciding to make everything as a code. So you have to specify data sources for Grafana, and of course our data source is Prometheus. Just like we indicated earlier that Grafana depends on Prometheus. So you specify the URL and then set the time interval for which to collect the data from Prometheus. Once this is done, if the data comes in, you need to create a nice dashboard for it. So this dashboard, the UI, is what's going to create the dashboard. This will be the name of our dashboard. And of course, the path is going to be Grafana provisioning dashboards. Okay, this exact location. Now for the dashboard itself, the design and everything, I've used a drift dashboard.json file here. And this is really up to you. You can do it manually in Grafana, but it's quite easy also using the JSON file here to create a nice dashboard. Okay, it's quite long, but it's very basic stuff, creating nice visualization. So you can easily go through this and let me know if you have any questions in the comment section below. So that is it for Grafana. So let's run our Docker Compose for everything to start running. Of course, this is our Docker Compose file here. Or when I start it, everything is going to start. So I'll use this command here, Docker Compose app d build. Now -d just means in detached mode. Press enter. Now this is going to create the containers and start running them. Now you will ask, how does the model service container start running? It's because in the model service, we specify the Docker file here. This Docker file is what creates a Docker container for the model service using the Python base app, which is 3.10 Slim. The app.py depends on all of these other files. So you have to copy all of them into that Docker container or image that we are creating. And the port is 8000. And this will be the command to run the app. Everything is running so far. So back in the README, we can do Docker Compose PS. And you should see all the 4 applications and their containers running like that. You can get the logs using Docker Compose logs and stuff. If you want to do individually, you can run this. I'm going to go to a different tab here. And of course, these are the logs from the model service itself. If you want to end the processes, you can use Docker Compose down -v. And if you add the flag RMI all, this will delete everything and remove the images that we created as well. Okay, so now that our Docker containers are running, you can go to another terminal here. Now you can verify the service health using this. Now remember the port for our app is 8000. So you can run these commands just to check. You can see it's healthy. And so of course you can go to your browser, go to localhost 8000, and you should get something like that. If you want to check the health as well, you just use the exact same command here or link and do /health, and you should see healthy. For the others, we have Prometheus. This should also be healthy. There it is, it's healthy. So Prometheus is port 9090, so you can do localhost 9090, and that should open up Prometheus. And then for the Grafana, you can check the health here. That is, you can see it's okay. Of course, Grafana is port 3000, so localhost 3000. There it is. All right, so the same are the links we have here. Lastly, you need to do Alertmanager. It's localhost 9093, and that is our Alertmanager right there. So far, there's nothing in there. So these are just the bare bones. Okay. Now for Grafana, before we do anything, you need to log in with username admin, password admin. But then you have to change the password with a new password. Okay. I'll give it some password that I can remember. So that's our Grafana. All right. Now for the Slack, you have to install Slack first on your system and then go from there. If you are working on Ubuntu, like I am doing right now, you can use Snap to install Slack. This is my Slack application right here. I already created a workspace for my channel, so this is it. I can use it to sign in. But if you don't have one after installing, just click create a new workspace and create one for yourself. Right? It's free. So I'll click here. Usually for you to log in, it will go through the browser and log in from there. So you see that now it's logged in. I have some channels here that I've used in the past. Now, first, let's see how you can create a Slack incoming webhook, which is also going to be our Slack webhook URL that we're going to use so that notifications are going to be sent by the Alertmanager to Slack. To create a Slack incoming webhook URL, I've given you the steps here. You first go to your Slack workspace, which is what you created from the beginning, and that's what I used to log into my Slack account. You go to File, Settings and Administration, Manage Apps. By the way, you see File right here, Settings and Administration, Manage Apps. And then you will search for incoming webhooks and click on Add to Slack. You search it right here. Now, currently, I've set up one in the past, so I will go to Custom Integrations. This is it. You see 3 configurations right there. Click Add to Slack like that. Once you add it to Slack, you can post it to any of the channels on your Slack application. If you come in here, all of these are channels. Or you can just create one from scratch by just clicking this, create a new channel for your project. I'm just going to pick one of the old channels. So these are the same channels that you see right here. So I'm just going to pick one of them. Add incoming webhook integration. Now that will create my webhook URL right here that I can use for my integration. You can also copy it right here, or you can also regenerate it in case you lose it. But it's always best to store it somewhere safe. And then back to our project here. Again, you can follow these same steps here. Once you have the URL, go to the .env file and replace the environment variable with the latest Slack URL. And then also in the alertmanager.yaml, replace this. So .env, I'm going to replace this here with the new Slack URL. Save it. And then in alertmanager.url.yaml, you have to replace this. But this has to be in single quotes. Save it. Once that is done, you can generate some traffic and see what happens. Now for generating the traffic, I have some file prepared here for test normal. So what we are going to do is to inject some data sets or some traffic. And for that, I'm going to use the test normal shell script. Now this is the test normal shell script right here. And this is going to do some predictions based on our model. And it's going to do about 100 of them. Now this should be able to collect some data. Okay. Create that shell script and of course make it executable using chmod +x like that. And then we can use /test normal to test it. The test normal file like that. It's a shell script. And it will create data like that. Now you see data coming in into the Slack. You go into the Slack here. You should see data sets coming in. You see it's firing all over the place. Now let's go to Prometheus. and we can make these queries. You should get some results for them. One is model drift score. Press enter, and these are the drift scores that we've gotten so far. Now you see some of them are KS tests, some are PSI. If you want to separate them, you can just specify a method equals whichever test you want to do, like this one. Press enter, and that gives you just the KS tests. Now you can also see if the alerts are actually coming in or not into the Alertmanager by checking this in the Prometheus with firing, and you see it's already firing. So if you go to the dashboard, or let's do Alertmanager first, refresh this page, you should see alerts being fired in here. Okay. When you go to the Grafana page to refresh this, go to dashboards, you should see the dashboard that we created, ML drift monitoring dashboard. That was the name we gave our Grafana dashboard.yaml. This is the name right there. Okay. So click on this and you should see all of this data coming in. Now, each of this data is specified in the configuration that I used. All of these features are inside this drift dashboard.json. Now, each of them means something. So we have about 9 different stacks on the dashboard. You have the drift score by features. That shows a bar chart, which is exactly this. You have the drift score over time, prediction rate, drift alerts, total predictions, etc. All of them are right here with the definition for each one of them. Then of course the alerts are triggered if any of these happen. You can refresh this as many times as you want to. By the way, when you run it on the terminal, you see whether it's severe, and you see the drift score for each feature. It will specify the threshold. All right. Now I'm just gonna do one more time, like this. And you see 56 new messages in. And then when you go to Grafana, you should see changes. These are the drift alerts so far. These are the total predictions we've done, 200 predictions. This is like a time series for the drift scores. These are the PSI drift scores. This is prediction latency, feature means over time, prediction rate. The data comes in every 15 seconds, but if you like, you can click refresh here just to refresh to get new data. Then of course, if you come in here in the Prometheus, you can always check whether it's firing or not. These are all the times it's fired. Let's do it a couple more times just to simulate the whole process. Get new messages here. Okay. It will detect some alerts in there. So far we've done 300 predictions. When I stop, these drifts will start stabilizing because I'm manually injecting drift. So with that, we've been able to build a drift monitoring system using Prometheus, Grafana, Alertmanager, and Slack notifications. By the way, I will leave the codes and all the instructions in the GitHub repository link attached in the description below. Please like, comment, and subscribe to my channel for more videos like this. Now, before we leave, I'm going to have to do a cleanup. I've created a shell script here called cleanup.sh. This will just run docker compose down -v. This will turn down all the containers here that are running via docker compose, and -v will just remove all volumes as well. Now, if I run this instead, it's just going to clean everything out and also delete the images that we built for all 4 of them. And then this will prune, basically removing all the volumes that may be dangling or hanging around. This will also remove any images that may be hanging. This is a total cleanup. So what I would do is, of course, it's a shell script, so you need to make it executable using this chmod command here. and then you can run / the name of the shell script. Paste it here like that, and this should get rid of every single thing. So the total cleanup is done, and you see how much space it's reclaimed. Now all our servers should be down. Prometheus should be down. Close all of this. Grafana is down. Alertmanager is down as well. And of course, Slack is also going to be down. Please like, comment, and subscribe to my channel for more videos like this. And I'll see you on the next one. If you have any video ideas or project ideas, keep them in the comment section below as well. All right, catch you on the next one.